Welcome to class 11 physics. Today we are discussing the first chapter in the plus 1 physics textbook, that is units and measurements. So first we'll be seeing what is explained in your introduction segment. So there the first question which is we have to answer is what is a unit? So the definition of unit is, see, measurement of any physical quantity involves comparison with a certain basic, arbitrarily chosen, internationally accepted reference standard called unit. Suppose you say there is two sticks. We have two sticks. Okay, this is one stick and here you have another stick. Let's name it as A and B. So I'm telling some person to measure the length of both sticks. And somebody measured it in 10 centimeter. Okay, somebody measured it as somebody measured it as say this is 10 centimeters. Somebody measured it as 10 centimeter, and somebody measured this like 0.005 meter. Say, in that case, I cannot compare it with, right? See, you can see from the figure itself that A is double that of B. But if you're referring to one is in meter, one is in centimeter, that means you cannot, compare. So for comparison, we have to stick to some same reference, right? So that same reference is basically what is unit. And those units which you are seeing today, that is centimeter, meters, kg, everything. Okay, everything has been now we are following actually SI unit system. In that we are using this reference. Everybody is using the same standard units, right? So because that is SI system of units is the present system which is currently accepted. Before that also there were some other system of units that we will see. Okay. So basically what you're saying that if you want to specify, if you want to compare two things, you have to, you have to compare it with certain basic arbitrarily chosen internationally accepted reference standard, and that is called unit. So unit basically it will be associated with some number like 10 or 5 or whatever, then that particular unit will be also always be there. So units basically, the units are classified as fundamental or base units and derived units. Okay, so fundamental or base units means that there are certain quantities which are, there are some quantities through which you can specify all the other quantities. So such quantities are called the base, fundamental units or base units. Okay, this fundamental or base units is the units for fundamental or base quantities. The units which are used for specifying the fundamental or base quantity is called the fundamental unit or the base unit. There are certain physical quantities which are referred to as the fundamental units through which you can, through their combination, you can represent all the other quantities. So that is the derived quantities. Okay, so the units of all other quantities, all other physical quantities can be expressed as a combination of base units. Okay, can be expressed as a combination of base units, that is called the derived units. We'll see in detail again. Okay, so don't worry. So these are the fundamental or base quantities. These quantities are being referred to as the fundamental or base quantities according to the SI system. We will soon see what is this SI system. Okay, so these are the fundamental or base quantities according to the SI system. So this fundamental or base units and derived units, these, that is, the units are of two types, fundamental or base units and derived units. So this is together known as system of units. System of units means that all these units, fundamental or base units and derived units, they are together called as the system of units. And according to the SI system, that is what we are referring to, presently accepted standard. That is the for for measuring the physical quantities is the SI system. According to that, there are 7 fundamental or base quantities, which is the length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensities. All the other physical quantities can be expressed as a combination of these quantities actually. We can specify their unit from this combination of the fundamental units. Okay, so these are the fundamental or base quantities. So the units for the fundamental or base quantities are the fundamental or the base units. And the units for the derived quantities, which are expressed as the combination of base units, are called derived units. So you see the international system of units. So now when I said here, these are the 7 fundamental quantities, I was referring to this SI system, which is the presently accepted system. So we'll see the international system of units. So before that also there were some other unit systems like CGS, FPS, MK. So CGS means here you can see length, mass, and time are some of the physical fundamental quantities. So in CGS system, length is measured in centimeter, mass is measured in grams, and time is measured in seconds. If you see the foot-pound system, here length is measured in foot and mass in pound and time in seconds. So if you refer to this MKS system, length is measured in meter, mass is measured in kilogram, and time is measured in seconds. Okay, so these are some of the units which were early used. Now the presently accepted reference system is the SI unit, SI system. Okay, because why SI system has been accepted is that there is this ease of conversion within the system. Like if you see, suppose if you want to convert kilogram to gram, then it is easy. You just multiply it with 10 power minus 3. If you want to convert gram to milligram, then you just multiply the gram with 10 power minus 3. That means ease of conversion. With powers of some 10, you can easily convert the, conversions within the systems are quite simple with this SI system. That's why it is accepted as the present system. So there are 7 base units in the SI system, as we have already seen. That is length, mass, time, electric current, temperature, amount of substance, and luminous intensity. So here length is measured in meter. Length means in SI system you have to specify its unit as meter, and the symbol is M. Mass is in kilogram. Symbol is kg. Time is measured in seconds, and the symbol is S. This is small s. Okay, and current is measured in ampere. Symbol is A. Temperature is measured in Kelvin. Symbol is K. And the amount of substance. When you are specifying the amount of substance, you have to specify whether you are referring to atoms, molecules, or ions, or whatever. Okay, so that is measured in mole. Symbol is mol, mole. And luminous intensity, it is measured in candela, and the symbol is CD. And you see, and yet you have 2 more units. So we have not specified about any angles, right? So you have this 2-dimensional angle, which is the plane angle, and you have this 3-dimensional angle, that is the solid angle. So angles which are formed by the intersection of 2 lines or 2 planes, that is the plane angle, and that is represented by d theta. Here you might have studied in mathematics, angle is equal to arc by radius. So the same formula has been used here. That is what is used. That is here angle is plane angle. It is d theta is given by here. In this figure you could see arc is represented by ds, radius is represented by r. And the unit for the plane angle is radian. Okay, radian, and its symbol is rad. Okay, when you are specifying plane angle in SI unit, that should be in rad and not in degrees. Okay, and solid angle. If that angle is formed by the intersection of planes, 3 planes, then that is a solid angle. So solid angle is represented by d omega. See, as always, d omega is given by the intercepted area. See, the area intercepted here is given by this one. This is a 3D figure. Okay, remember, this is a 3D figure. Here, so you are specifying the 3D angle, d omega. So that intercepted area divided by square of radius, that is given by solid angle. And its unit is steradian. Its unit is steradian and its symbol is SR. Okay, it is represented by the symbol SR. Okay, so these are the SI units. And yeah, here we are saying these are the base units, right? Length, mass, time, electric current, temperature, and unit of substance, luminescence. Now we'll see derived units. You have to see some examples of derived units as well, right? So derived units means that it will have a combination of this base units. So in the textbook, in your appendix part, actually there are a lot of derived units. So many tables are given. You could refer to that. But for simple examples, I will tell you. Suppose if you take area, area is basically if you take the area of a square, that is, square is having dimension A, then its area is A square. If you consider rectangle, which is having dimensions A and B, then its area is AB. So basically, you are multiplying a length with another length. So you have basically length square. Length is measured in meters. So this is meter into meter, meter square. So you're seeing something, there's a combination of this base unit here. So this is the SI unit for area, but this is not a fundamental quantity. It is not a fundamental quantity. Fundamental quantity is meter. Here you are having meter square. So this is a derived quantity. Also, you could see something like a speed. You see speed, you know the formula. Speed is distance divided by time. So distance is measured in length and time is measured in seconds in the SI unit. So this is the unit for length is meter and for time it is seconds. So meter per second. You can see another derived unit. Apart from this, you have some other derived units also, like for frequency. See, for frequency, it is 1 by time, as you know, the formula for frequency. So this 1 by time means 1 by time. Okay, so 1 by time means time is measured in seconds in SI unit. So second inverse is the unit. So this is being given a special name. It is called hertz. Okay, so special names are also being given to some quantities. At another quantities, that is also a SI unit accepted names. Okay, pressure. For example, pressure, the unit for pressure, it is given a special name, that is Pascal. This is basically kilogram per meter second square. Like that, you can see some other physical quantities also. And there are some special units are also being given. Okay, like not units, some common prefixes and symbols are there for multiples and submultiples. Like you can see, if it is 10 power 6, we will call it as mega. We'll call it as mega. And the symbol for representing that is capital M. Okay, but if it is 10 to the power minus 6, then we'll call it micro. And that symbol is micro. So if it is 58 into 10 power 6 meter, you can represent like 58 mega meter. Okay, so if it is 58 into 10 power minus 6 meter, you will say it as 58 micrometer. Like that, some things are also accepted for in the SI system of units. So there are a lot more examples. Everything is given in appendix. You can just go through, but no need to by heart everything or anything, because throughout, when you go through all the chapters, you will familiarize. Easily you will familiarize and get to know everything. You will easily understand and by heart everything. So no need to by heart all at once. You just go through it and see, and just you can appreciate everything. Okay. And these are some units which are retained for general use. Like if you specify 1 minute, means that the symbol is for specifying minute, you'll use the symbol min. And if you want to use it in SI unit, how you will see 60 minutes constitute 60 seconds constitute 1 minute. So 1 minute. So 1 minute means it is 60 seconds. See, hour, the symbol is, if you want to specify hour, you can use H, but then that value of in SI unit is, 1 hour consists of 60 minutes constitute 1 hour. That means 1 minute has 60 seconds. So 60 minutes means 60 into 60 seconds is 1 hour. 60 into 60 is 3600. Like day. If you consider day, 1 day means it is 24 hours. And 1 hour is 60 into 60 seconds. So 24 hours means 24 into 60 seconds. That is 86,400 seconds. Likewise, 1 year means 365.25 days. So 1 day means 86,400 seconds. So 365.25 days means 365.25 into 86,400 seconds. That will give you this result, 3.156 to 10 power 7 seconds. And if you want to specify in degree, you can use this simple. And 1 degree, this conversion is very important for problems because in SI unit, the angle is, the unit for angle is radian. So you have to know this conversion. 1 degree is equal to pi by 180 rad. And this is also yet another important thing. 1 liter, you see 1 liter is 10 power minus 3 meter cube. This is also yet another important unit. Okay, just remember. And you see 1 bar is 10 power 5 Pascal. This is important to learn. And you see standard atmospheric pressure means you are referring to 1.013 to 10 power 5 Pascal. So while doing problems and all, you will easily familiarize and you will definitely familiarize. So no need to strictly by heart all at once. That's fine. So in next video, we will see about significant digits, significant figures. Okay. So thank you.